everyone, in this video we're going to take a look at the property for limits, the limit of a power. Now the first thing we need to remember is the property we've already talked about, the limit of a product. So remember that theorem says that the limit as x approaches c, and if we have a product of functions, we can separate this. So the limit of a product is the same as the product of the limits. So this is the same as the limit of f of x times the limit of g of x. Now I want to consider something a little bit different. So what if instead of two different functions, what if it was the same function? So what if we had the limit as x approaches c of f of x times f of x? I could still use my property to separate this into the limit of each one individually. So the limit of f of x times the limit of f of x. Now, multiplying a function by itself, I have another way that I can write this. So instead of writing this as f of x times f of x, I could write this as the limit as x approaches c of f of x squared. And then I could follow the same process and I would end up with the same exact thing. And if I look at this, I have a limit of f of x times itself. So these are the same thing multiplied together. So I have another way that I could write this. So from here, if I go one step further, this is the same as the limit as x approaches c of f of x, and then this entire piece is squared. So using this property, the limit of a product, if we just use the same function inside, we can end up with a new corollary that is our limit of a power. So our corollary, the limit of a power, states that if you have the limit as x approaches c, and then a function is raised to a exponent, let's call it n, this is equal to that limit raised to the power. So the limit as x approaches c of f of x, and then the whole thing to the power n. Okay, now let's use this property in an example. Okay, so here's the limit I want to investigate. I want to find the limit as x approaches a of this function x squared minus 2x plus 1, and then that whole piece is squared. Now, one thing I want to get in the habit of is whenever I'm looking at these functions, I should try and see if I can simplify them at all. If I could rewrite it in something that, in a way that's going to be useful to me. In this case, if we look at this trinomial, x squared minus 2x plus 1, just based on the pattern here, I know that this is a binomial squared. So I know that I can factor this. So what I'm looking for, two numbers that multiply to 1 but add to -2, well, that's -1 and -1. So let's rewrite that. So the limit as x approaches a, and then we have x minus 1 times x minus 1. Well, I'm going to write that as x minus 1 squared, and then that whole thing is still squared. So what I did there is I took this trinomial and I factored it into a binomial squared. So here I have something that's raised to a power, raised to another power on top of that. I can just multiply these exponents together to simplify it even further. So the limit as x approaches a of x minus 1 to the 4th. Okay, now let's use our new corollary, so our property. Our property says if we have something raised to an exponent, we can change that into the limit as x approaches a of the function, and then we can take this whole thing and raise this to the fourth power. Now the reason that this is useful is because now that the exponent is around the limit, what I'm left with on the inside is a little linear function. This is just a combination of the identity function and a constant function. So we know how to simplify that already. So with a little bit of substitution, this is what we end up with. So the limit as x approaches a of x minus 1, that simplifies to just a minus 1. So that piece, so the stuff that's on the inside here, so this limit, that's the same as this piece here. So this is what it simplifies to. And I still have my exponent to the fourth power. So this limit is equal to a minus 1 to the fourth. And that's how we use the limit of a power.